We are learning about four-sided figures, namely quadrilaterals. So let's explore the properties of quadrilaterals one by one. So a quadrilateral basically can look like this or this way, or it can just be a simple square equal all four sides equal. Whatever the case is, there is one property which is common to all of them, which is the sum of interior angles. The sum of interior angles. You may recollect that in the case of a triangle, we saw that the sum of the angles in a triangle, all these interior angles, this angle here on the vertex, this and this, they add up to 180 degrees. This is a property of the triangles. It is called the angle sum property of triangles. Similarly, we also have a specific property for these quadrilaterals, the sum of the interior angles, and let's try to derive what it is. Now let me say that this is a quadrilateral, and if you connect the consecutive points or the adjacent points in a quadrilateral, so these are the adjacent points, right? If you connect the adjacent points, we get what are called the edges of the quadrilateral. If the adjacent vertices are connected, we get the edges of the quadrilateral. What if you join the non-consecutive points? So I am joining this point to the point which is not consecutive, that is, which is not adjacent. So what the line I obtain now, the line segment I obtained by joining these 2 points is called the diagonal of the quadrilateral. Now we can look at this figure. If ABCD, if we name this quadrilateral as ABCD, this diagonal has divided the quadrilateral into 2 triangles, right? So one triangle can be called as triangle ABD, and the other triangle can be called as triangle BCD. So the quadrilateral has been divided into 2 triangles by the diagonal. So now we can say that the sum of the angles, so in triangle ABD, these white, the ones I am marking, the angles are marked in white by me, the sum would be equal to 180 degrees. And similarly, in triangle BCD, these 3 angles in green would be equal to 180 degrees, right? And these are the 4 angles. These all these angles. This is of course divided into white and green, but it is one single angle here, right? It is one single angle here. So all these 4 angles make the interior angles of the quadrilateral. So the sum of the angles would be equal to 180 plus 180 is equal to 360 degrees. So the sum of interior angles of a quadrilateral is equal to 360 degrees. Here we have proved the sum of the angles in this quadrilateral using this property, angle sum property of triangles. Now, what if I am not using triangles? There is one more way. There is another interesting way of proving the sum of the angles of a quadrilateral. Let me say that this is a quadrilateral, and let's not divide it using the diagonal. Instead, let's just say that there is a point P on the quadrilateral, anywhere within the quadrilateral, in the interior of the quadrilateral, and let us connect the vertices, all the 4 vertices to the point P. So this is connected, and this is the second vertex is connected to P. The third vertex is connected to P, and the fourth one also, right? So what do we have now? We have 4 angles formed here, right? This is one angle, this is one, this is one, and this is one. There are 4 angles formed. And at the same time, we have 4 triangles also. If I call this quadrilateral as quadrilateral ABCD, we have 4 triangles, namely triangle APB, triangle BPC, triangle DPC, and triangle DPA. We have 4 triangles, right? So what would be the sum of the angles in all the 4 triangles? It would be equal to 4 times 180 degrees. Correct? This is 180, this is 180, this is 180, this is 180. So all of them add up to 4 into 180, which is 8 4s 32, 720 degrees. So the sum of all the angles is 720 degrees. So now what we require is the sum of these 4 angles, right? So this would prove, this would be our requirement now, because we are trying to explore the angle sum property. It's popularly called as angle sum property in a quadrilateral, of a quadrilateral. So we need these angles in green. So we'll have to take away the angles in blue from these green angles, right? So what is these angles in blue? They are angles around a point P. So they would add up to 360 degrees. So we just take away 360 degrees from 720 degrees. We would get the sum of the interior angles in a quadrilateral. So what is this equal to? 0 minus 0, 12 minus 6, 6, and 6 minus 3, 3. So this is equal to 360 degrees. So once again we have proved that the angle sum property of a quadrilateral, or the sum of the interior angles of a quadrilateral, is 360 degrees. And this holds good for any type of quadrilateral. The quadrilateral can be of any type, any shape, this or this. We'll of course read about all these shapes further on in our upcoming videos. It can also look like this. So the sum of the angles of a quadrilateral would always be equal to 360 degrees, however or whatever shape they might take, provided they are four-sided. I hope you followed. Thank you.